Congratulations, you made it to Module 4. Module 4, we're going to look at how you deal with collections of data. So we'll look at strings, tuples, and lists. They're all similar, but of course they're all different, and you'll see how that is true. So, best thing to do is to get started. Let's start with collections, other words known as sequences. So many programming languages, and I would say most programming languages, will allow you to manage a collection of data as a single variable. That way you can collectively refer to those items and access the individual values whenever you want. In Python, these are known as sequence types, but other languages typically call them collections. Now there are different syntax based on the type of collection or sequence you want to use. And the ones that we use in Python are double quotes for a string. There's a function called range for a range sequence. There is parentheses for something called a tuple. In other languages, this is called an array. And square brackets for something called a list, which is very similar to an array, but it's got, or tuple, but it's got a lot more features. Now, once you put values in, like in my particular case, I've put values 1, 2, 3 in the string, the range, the tuple, or the list. In all of these, you can access the individual items in that collection by using an index value. This is actually known as a subscript, but since I'm using a number, it's an index. What I mean by that is subscript is the generic term, index is the type of subscript that it is. There are some subscripts where you actually use text instead of a number. In most languages, I would say pretty much all languages, the numbering system starts at 0. So it's 0, then 1, then 2, then 3. That isn't always true, but it's a pretty safe bet that that will be true in whatever language you're using, and certainly it is true in Python. Now typically, if we have a collection of values, we want to loop through those values. We want to grab a value, do something, grab another value in the collection, do something, grab another value in the collection, and do something, and so on, until we run out of values in the collection. So a very classic example of working with a collection of data would be to create a loop, like this one. So I'm going to create a string, which is a collection of individual characters. That's character 0, character 1, character 2. I know it's kind of confusing because character 0 is the value of 1. But that's the way the numbering system starts off. Now I'm going to make a while loop, and I want to make sure it doesn't go over the amount of characters in there. So I'm going to set the counter at 0 and ask the question, is the counter less than 3? The reason why I want the counter less than 3 is because it's 0, 1, and 2. So it's got to be less than 3. And I'll print out whatever character I'm looking at based on this index value. So index 0 will give me the value of 1. Index 1 will give me the value of 2. So in this particular case, what I've got going on is it would print out 0 first, because the counter is set to 0. Then would take the counter of 0, add 1 to it, set the new value of 0 plus 1, 1, to the counter variable. Start the loop again. This time is 1 less than 3? Yes. So it prints out 1, which is the value of 2, bumps the value up to the next number, which is 2. Is 2 less than 3? That is true. So the counter becomes 2, and we get the value of 3. Index of 2, value of 3. When it bumps it up to 2 plus 1 equals 3, and asks the question, is 3 less than 3? That's no longer true. That is not true. 3 is not less than 3. It's equal to 3. And so the loop stops running and you get your results. That's a very classic way of working with a collection, and that would work with a range of data, a tuple of data, a list of data, or as you saw here, a string of data. You would just use that index subscript to access the individual values. Another way to loop through a collection is a for loop. Now, the nice thing about a for loop is it's specifically designed to do this. And so the developers made it automatic. You don't have to actually create a counter variable, and it will automatically stop. So you don't have to do some kind of increment to change the counter to bump it up to 1, nor do you have to put any conditional logic to examine whether or not you've exceeded the number of values in the collection. It's all automatic. So if I look at this result here, I've got the string, I've got the range, I've got the tuple, I've got the list. I use this syntax here. First of all, on the string, so I've got my string of data. And for each item in the string, I will print out the item. Now notice that I just made up this name, item. You can make up any name you want. But I'm referring to an item in the collection. In this case, my string. So the individual string value, character values in that string of characters. A lot of times people don't want to type out the whole word item. They just use I. And that's very popular. I'm not entirely sure that you need to type out item, but in a classroom environment, I like to be clear, take truth. Even when I'm developing in professional environment, I like to be clear. I think people get so used to seeing the shortened version up on a discussion board on some random website that they think it always has to be that way, but it doesn't. Anyway, you just make up something. And you'll notice that the syntax looks the same for the string, the range, the tuple, or the list. It really doesn't change. What changes is which collection you're working with. And the result doesn't change either. Now they are different types of data. The first one is a string, the second one a range, the next one tuple and list, but they all print out the same thing using pretty much identical code. The only thing changing is which collection I'm looking at. And that really makes it convenient to work with. So whenever you're working with a collection of data, while you can use a while loop and control it, you'll be able to get manual control of it and maybe even do things like skip every other row. With a for loop, it's automatic. And although you can put some programming logic inside of the code the for loop is going to process, you don't have to put anything to actually count the number of items or anything like that. It's just done for you. Very, very convenient. Like I said, strings are a collection of characters. And each individual character is useful all by itself, but not as much as the collection of characters. That actually has significance to the human. So we definitely get used to working with this collection of data. You indicate that you want a string by using a single quote or a double quote operator. In Python, it doesn't matter. In other languages, it may. For example, if I'm using the database language of SQL, it has to be single quotes. Double quotes will not work, as a different meaning. But you will have to test. Each language you come across, you'll have to test, read the documentation, look on the internet, whatever it is. But again, in Python, it doesn't matter. Just choose one in that one script you're writing and be consistent. As I've already shown you, you can access the individual characters by just using an index value for the subscript. So string data sub 0, string data sub 1, sub 2, sub 3. Of course, sub is a a shortened version of subscript. And you can see it prints out the values. Notice that when I print out the value with a separator, separator is part of the print statement. It makes it so that I can print out the little vertical bar. Vertical bar is above your enter key on the keyboard. The commas I'm separating the values with are indeed considered characters. So any additional syntax that you put in to your string is going to also be considered a character. And notice that these characters are actually numbers, but they're held as individual characters in the string. And of course, I could have put A, B, or C, but I wanted to talk about this talking point, that a string is a collection of symbols, characters, and numeric values. So quite a lot of things can be held in a string, and you have to treat it like a string while you're programming with it. And perhaps if you want to do some kind of calculation or something like that, you convert it over to a floating point value or integer value, or strip out the individual punctuation characters. The string class is a tool that we use to create a collection of functions and data. We'll look at that in a later module. But the string class has a bunch of built-in functions. So these classes that you make in Python are a way of organizing a set of functions, and the string's functions include these: lower and upper, strip, which we'll go through and remove like blank spaces. That's actually really handy when you're working with user input, because sometimes they put in extra spaces that you don't want. Replace, which case you search through the string, find something, replace it with something else. You can optionally go ahead and indicate how many of those replacements you found. So if I was looking for a number of 1 and wanting to replace it with 10 inside of a string, every time I found 1, I could replace it with 10, or I could only do it on the first time I found it, or the second time I found it. So the count is an optional feature. I can tell that because of the square brackets. When you're looking at help documentation, if you see square brackets, like here, it will be an optional feature. Like on this one here, the strip one, the optional feature is if you don't specify, it'll assume that you want to remove the spaces. So the non-visible spaces, if you specify a character, it'll remove those. So like if I have a long string and it has a semicolon at the end, I could remove that semicolon by indicating that's the character I want to strip off. Another one is it an actual character? Not a number. Is it character data? Is alpha? Split is handy. Split allows me to go through and separate the individual characters in a string into some other collection of strings. Here's some examples on how that would work. So first of all, lowercase, uppercase, and replace. Those are pretty simple. So lowercase, I have my string test data. Where's my string? Looks like I'm missing a little piece there, guys. Let me see here. Knock the... Okay, so first of all I had test data, and you can see when I use the lower option, it prints out test data, lowercase. When I do the upper, it prints out test data, uppercase. If I replace the space in between there, so whenever you find a space, replace it with dashes, you can see how that works too. So the dashes show up. Now if I go through and I create this test data with spaces, I got spaces in the middle, I got spaces at the front and the back, and I use strip, and I don't indicate what I'm stripping off, it'll assume I'm stripping off spaces. And as you can see here, the front space and the back space are actually gone. Well, you can't really see the backspace, but it's gone. But the one in the middle isn't stripped out. So strip only works on the front and the back. Is alpha is interesting. If I put in an ABC as the string, that's true. 1, 2, 3, that's false. If I mix it with ABC and 1, 2, 3, that is also false. And split, if I'm splitting on a comma, what I end up with is a list, a different type of collection, a list of individual characters. And I can print out 0 and 1 and 2, which would be 1, 2, and 3. You can see that down here. And the separator allows me to, and the print function allows me to separate them with that vertical bar. You'll use split quite a bit. It's a very handy function. It shows up in many languages because it's just so useful in splitting up data from a collection back into individual values. Now strings can be printed out using a number of different features. One of those features that is useful on a string is the format function. Now the format function, I can either use a variable, put the value in a variable like str data. Actually, let me just show you. So I've made a new project for our demos today. And let's paste that code in. So when I run it, you'll see that what it does is it replaces these little substitution arguments. These are the arguments, and these parameter values are being passed, or excuse me, these are parameters, and these argument values are being passed into the parameters. These are called substitution parameters. Placeholders, another term for it. So placeholder 0, placeholder 1, the 47 goes into placeholder 0, and the 11 goes into placeholder 1. And as I was saying, you could either use the string itself or use the variable. Typically when I see it, I usually see the string, putting a dot notation on the string and doing it. But notice that I get all these functions from PyCharm's help option, showing me all the functions that are built into the string class. There's a lot of them. Some you use all the time, like the ones I'm kind of pointing out, and other ones not as much. But certainly the format function is pretty handy. You can also see another version of that function. It looks like this, in which case, actually I think I'll just show it here. You, instead of using 0, 1, 2, 3, 4 for the substitution, you can give it a name. So the parameter name is column 1, column 2. From, this is another one, I guess I should put that in there. Change, add a color here. And you can see that employee ID will go into column 1, select employee ID. Employee last name will go into column 2. And then employees will go into the table. So it's a nice way to build a string using this option. You can use either a index to indicate which substitution parameter is, or a name. This is when you use a name, they call it a key. When you use a number, they call it an index. But these are very similar to those subscripts I was talking about. But they're called substitution parameters. There's actually a few different ways that you can do something like this. One of them is to use these options in the string. These are the replacement operators. So there's one called %S, another one called %D. There's a few other ones, but I got to tell you that these are the two I use most often. You probably will too. D for digit or decimal. Decimal just means a base 10 number. So I usually call it D for digit, easier to memorize. And S for string. So you print out the D for digit, 47 would go in there because it's the first one it comes across. And Bob Smith would go in the next one because it's the next one that comes across. Now, do keep in mind that if I had a digit here, it's not happy. It wants a number. It needs to be a string. So using this feature enforces the data type, which can be useful. A little more precise than the previous one I showed you, which would accept anything. You'll see other options out there, like the F string, in which case you can go through and just put an F and start putting code in there. It'll basically do the same thing. And of course, other people will come up with other variations of this. I see this one in a number of languages. The F string one I see in C-style languages. It doesn't really matter. You'll pick them up once you've seen a couple of versions of this. You'll pick up how these work in no time at all. Just know that they exist in various different forms when you're working with strings, because a lot of times we want to build a string. So we're going to build pieces of a string by using values from either hard-coded values, like typing this in here, or sometimes, quite often, we'll use variable values. I'm going to get some input from the user, and I'm going to use that string here. So it's waiting down here for me to put something in, and see how it went ahead and picked that up. So by using a variable value, we can change the string based on the user's input. It's kind of interesting to note that when I change a string, so if I have a string and I add values to a string, let's say I have a string of 1, 2, 3, and I want to go ahead and add a fourth value to the string, I can do so by just using this syntax. Or I could take out the comma. Same variable, no commas, and it works. Although the change seems to have taken place in the original variable, in all of these cases, it's actually not exactly true. Turns out that for performance reasons, typically, there are some times where the collection is immutable. What that means is that once the value is set and stored in memory, you can't change the value. You have to just recreate a new one. Changing the value is more expensive than tossing out the original one and getting a new one. And as such, these immutable collection of items are the ones that are used on a regular basis so often that they assume it would be best to kind of tune the system to give you the best performance. So strings are immutable in most languages, and although you can't really tell, if I use this code, I can't always tell that something has changed. So if I take this code and I run it, something has changed, excuse me, that the data in memory has changed, is what I mean. To me, it looks like it's working exactly as I expected. It was 1, 2, 3. I put in 1, 2, 3 without the commas. It prints that out. It looks like it's changed this, but actually it's a different string in a different spot in memory. And if I add on a 4, it just changes. It's really another string in memory, but maybe I don't care. Do be aware that if you try to change an individual value, an individual character in that collection, this is where the immutability will show up. See, I get an error message. I cannot assign a new value because I can't just change an individual value in the existing string. I have to toss out the old one and get a new one. Most of the time, things just work naturally. Behind the scenes, they toss out the old one, give you a new one, and you don't see the change. You don't see all the things that are happening in memory. You don't care. And you can't add additional items on either. So you can't change an existing value to a new value, an individual character to a new value, nor can you add on a individual character. Remember that we have 1, 2, 3, 4. Actually, I guess this would be the 4th number. But even if I do this, this won't work. It does not support an assignment. I can't add that in. So strings are immutable. You're going to read about it. You're going to see it mentioned on websites. You're going to read about it in the book. And you can visualize it like this. The string was originally pointing to address 177. But when you made a change, like you said, okay, variable 1 is now going to be a combination of variable 1 plus a space plus variable 2, it looks like variable 1 has changed its content, but what it really did was change its address. It went and pointed to a new variable with the new data in it, and the old one, the reference is no longer there. Eventually, Python's going to sweep through its little runtime area, its memory area. It's going to find that this variable at 177 is no longer being used by anybody and clean it out. This is called garbage collection. And it's a handy system because back in the old days, you had to make sure you cleaned up your own garbage. You had to make sure that you deallocated address 177 manually. This is why there's so much importance placed on the fact that things are immutable. Because back in the early days, it was important that you knew they were immutable and that you would have to clean up things by creating a new object, putting the data in there, and then deleting this yourself. And as such, as people wrote books over the decades, they continue to copy and paste the sentence that something is immutable, not really telling you why that was important. It's less important now because, well, it cleans up automatically, but it's still kind of good to know about, and certainly when you're reading those things and trying to understand why they're telling you that and what the significance is in your life, that's important to know so you just understand what they're talking about. So anyway, it's pretty much invisible to you, but it's a piece of knowledge you should know about. There's a feature in Python that's called slicing that you can use on a string. So it looks like this. You put a square bracket, you put the starting number and the ending number with a colon in between, and finish it with a square bracket. In doing so, you'll get the 0, 1, 2 second character and the third character. Oddly enough, you don't get the fourth character. So while the 2 at the beginning is inclusive, it includes the second value, the 4 is not. It's exclusive. So it doesn't include the fourth value. That's kind of strange. In some languages, this is true. In other languages, it's inclusive. So you have to always check. This is definitely one of those situations where you need to double check, always, whenever you're dealing with a new language. But in Python, that's the way it works. So if I were to run this code, I would see C1, because that is the second and the third element value inside of that string, or character value inside that string. Element is just a generic term for each individual element of that collection. Another thing that you do with strings all the time is to write them to a file. The reason for this, of course, is that when you make a string variable and you use it, you put data into it or you pull data out of it, that's all happening in memory. But if you want to persist that string, you need to store it someplace on the hard drive, and typically this is going to be some kind of text file where you store your strings. These text files are often separated by characters like tab characters, which are invisible, comma characters, which is my preference because they're visible. Those are definitely two common choices. You can kind of see here the way this works. First of all, we'll open up a file. If I don't specify where the file is, it will assume that the file is right next to wherever my script is, same location. That's a great way to conveniently work with the file instead of giving it a hard-coded path. Hard-coded path would mean I'd tell it exactly where it's at on my desktop, in the documents folder, on the _Python class folder on C drive, wherever. So with this, it's just relative to my script. And it's going to look for a file called mydata.txt. And if it exists, it'll use that. If not, it'll just make a new one. The W indicates that I want to write into the file. There's an R for read and an A for append. If I use A, it'll just add data to the file. If I use W, it'll replace the data in the file with new data. So once I use the open function, I will now have a brand new file with a connection to it through this variable object f. I like to put a prefix on here to indicate that this is a file object. Another term for that is a file handle. Other people on the internet will make it short and just put F. It doesn't matter, it's just a name they make up, name I made up. Use the write command to write the data. And we already know how to escape a tab so that a tab shows up. And if you look at the results, you can see that there's a tab in between. Or if I put a comma there, my preference, you can see the comma in there. I also put it in the new line in here. So in some cases, depending on the operating system that you're using, you may have to put new line and carriage return. So double check to make sure it worked. But on Windows 10, all I need to put is an N. And I believe that's true also on your Mac as well. Just some older versions of Windows OS, I think, is where you need to do that. But it really depends, so just to always double check. These values, like first name and last name, separate by comma, are very useful in the computer industry. So much so that sometimes instead of writing these files out with an extension of a TXT for text, people put in CSV for comma separated values. But a CSV file is just a text file that you expect to have comma separate values in. They're no different than any text file, other than the fact that you're indicating that the format's going to be with commas in between each value. Each one of these lines or rows of data, that's one row of data, that's another row of data, it's certainly legitimate ways of storing the data. It's just that the individual tab is not as user-friendly. Much harder to troubleshoot when you've got like 2 tabs in there. Sometimes the space is not as large as you might think for 2 tabs because it kind of it adjusts based on previous characters. Next, let's take a look at tuples. Strings are probably the first example of a collection that you start using. But tuples are another example of a collection that you'll find quite useful as well. These are often called arrays. In other languages are called arrays. In Python we call them tuples, and that's what we'll continue to call them in this course. The way you set up a tuple is, instead of using double quotes to indicate a collection of characters, you use parentheses. And instead of only being able to store character data, it can store all kinds of data. So integer values, strings, Boolean values, floating point values, all kinds of things. So tuples are much more flexible in that regard. And you still access the individual items using a subscript. In this case, I'm using an index. They don't have an option to use a key, so it's always going to be a number. 0, 1, 2, 3, just like you did with the characters of a string. You can access the individual elements of the tuple using that index value as a subscript. And you can see that when I do, I pull out the ID of 1, the name, Bob Smith, the phone number of 555-3445, and the Boolean value of true. The whole tuple itself, if I print it out, it'll print out, oddly enough, with the parentheses intact. Now notice that when it prints it out with the commas in there as well. That's not because the commas are part of the string or the parentheses part of the string. That just happens to do with the way that the developers set up their tuple class. Tuple is indeed a class that's built into Python. And like I said, we're going to talk about how to make your own custom classes later on. And you'll see how you could make this behave the same way. But at the beginning here, don't worry about it too much. The fact is if you use the print function and you tell it to print out the tuple, it uses the default format with a parenthesis and a comma between each element. Now in Python, you don't actually have to use the parentheses when you want to create a tuple. It can use the collection without them. It'll assume that if you make a single variable and a collection of comma-separated values, it will assume that you want a tuple. This is known as tuple packing. It's a convenience. The convenience is you didn't have to type out the parentheses. I'm not sure how much of a convenience that is, but it's a convenience nonetheless. And certainly on certain occasions, such as if I use input, I can capture the input and then chop it into individual values using the split command and fill up that tuple that way. But be it as it may, the fact of the matter is the two tuples that I'm creating here, tuple 1 and tuple 2, are the same thing. They're just using a different syntax. Notice that when I print out tuple 2, I still see the same format. Again, that's because it's not mimicking the way I typed in the code. It's actually performing a hidden function that converts it into a string of characters for presentation with the parentheses and a comma between each value. Now you can see I've got 2 tuples here, and they represent a set of values. I always think of them as a row of values because I use spreadsheets all the time and databases all the time, and it makes a lot of sense to me. I think it does for a lot of people. So you can think of a tuple as a row of data, if that helps, and I think it will actually. It's a row of data that you hold in memory. Now, like a string, as I showed you earlier, we can loop through them using a for loop. We can also loop through them with a while loop. Same thing. I can use the length function to find out how many items are in the collection. 1, 2, 3, 4. So there are 4 items or values or elements, fancier term, in that collection, in that tuple. And as such, I'll keep looping through there until I run out, using the counter to compare whether or not I've gone to the top of that list, or top of that scale, 0, 1, 2, 3. So this will give me the length of 4 elements. And then as soon as counter reaches 4, it'll stop looping. Notice that I've changed the syntax a little bit here. Instead of doing this, oops, I get back there. In the previous example, I'm using the shortcut version like this, plus equal, handy. But notice that now when I print out the data, it's printed out vertically. I am no longer using that built-in feature where I print out a string in a predefined format, predefined by the people that made the tuple class. Instead, I get my own custom format. Now, that's useful, especially if you want to control how the data is stored in a file or presented to the user. So keep that in mind as you go through your homework. Of course, you can use a for loop like I showed earlier. And if I do that, I can print out each item in that same vertical format. I'm not printing out the tuple, I'm printing out each item in the tuple. Just like you can pack a tuple by making a comma separate list of values, or collection, or comma separate set of values, I should say. I'm trying to avoid using the word list of values because list is another collection in Python. It's similar to tuples but has more features. So another set of values. And you can pack the tuple that way. You can unpack the tuple as well, like this. It's convenient. So you can declare 1, 2, 3, 4 variables. One to hold each of the values or elements in that tuple, and unpack them with the syntax. It'll automatically take the 0th one and put it in the first variable, the first one in the second, the second one in the third, and the third one in the fourth. I know, being zero-based makes it confusing. Many of us have lamented the fact that in programming they decided to start with 0. In fact, some languages, like I said, start with 1 to try to fix that, but they're pretty rare. And so, yeah, I just have to remember that it starts off with 0 and just kind of deal with the confusion. But notice that by doing this, I'm able to extract out the data and present it in a format, a custom format. So for example, let's say I want this to look like a table in a spreadsheet. And it's not going to be great, but let's say I go ahead and print out ID, name, phone number, current, is customer. Yeah, is current customer. Let's see, this is not. This is not well formatted. Is current customer. There we go. When I run this, it'll print out that heading, and then I will have the various different columns of data that I can pour my values into. So that's a convenient way to kind of present it to the user, because people are used to using tables of data. There we go. Looks a little better. I don't know. Lining these up just right to make it look pretty can be kind of tough. I'd have to do some stuff to it to make it look pretty, but that's good enough. Certainly, it's different than if I were to just print out the tuple all by itself. I get to control it this way. Why don't you pause the video and see if you can create a script that uses the tuple to hold this data and print it out. Print it out like this with ID, name, and email. I'm not using the vertical lines this time. I'm actually just using spaces. And then for the data, I'm just putting a comma separated list in here. But notice I don't have any parentheses. See if you can make it match that. I'm not so sure this is the best format, but it'll be interesting to see if you can make it match. Okay, we'll come back here when you're done. Okay, let's see here. I started off with my header and some pseudocode. Not great pseudocode, but it gives me a start. And I guess the first thing I need to do is create a tuple. Next thing is print tuple. Actually, let's do this. Let's also add an option to print out a header. Header in the table. So we'll say table header. And that's what I'm kind of looking for. Let's see here. Okay, so first of all, let's go ahead and create the tuple. So TPL is the extension, prefix I like to use. And then it can be called anything. Let's call this first one header. And then I'll put in ID, name, and email. Now, if I use parentheses, that works. If I leave them off, that works too. If I leave them off, they call it tuple packing. We're going to print the header. So print, and I want to print out TPL header. Let's see if it runs. Kinda. It runs, but I'm getting the default format, and I didn't want that. So let's fix that. We're going to print out item 0, or element 0, followed by element 1. I'm copying and pasting. And element 2. And we try it again. Yep, that looks pretty much like the picture. Now we could spruce it up a little bit by putting in here a separator other than the default separator, which is a space. And that definitely works. It doesn't look the same as this. So if you leave off the separator, it'll default to a space. If you want it to be something else, you put that in there. But I'm going to go ahead and try to match the picture, so I'll leave it as it is. Okay. Moving on to the next piece. The next piece was, how can you print out a tuple as a row? Okay, create the tuples. TPL row, and that's going to equal this data here. And copy. Now I'm removing some invisible characters there because I don't trust Word. When I copy and paste things out of Word, often, I have to be very careful about invisible characters that it puts in there. And let's see what it looks like. Print. We run it. There we go. Doesn't look like what I want, but we're moving in the right direction. It's working. So let's go over here and fix it. Now remember, we can either just use the indexes to pull out the values, or we can use that feature where we put a set of variables here and unpack the tuple. Now, using individual letters like that is not really intuitive, but it will work. So it'll be I, N, and E. And if I want to change the separator, I can. That should work. Let's see if it does. Yep, it did. I mean, there's all kinds of ways you could have done this. I could have made a string with comma 1, comma 2, and then passed in those values using the format function. Oops, semicolon. I guess I don't need that. Just force a habit. Same thing. And if you did it that way, perfectly fine. If you use the substitution parameters with, let's see, these would be strings. So if I went through and I did the %s, and then passed in the values into that, that would be fine too. Oops, I forgot that other feature. Let's see, you're happy? Oops, no comma. There we go. Same thing. Lots of different ways to do it. So hopefully you got one of those variations or something similar. Again, your code doesn't have to be exactly like mine in order for it to work, but that would be the way I'd kind of approach it. It is possible to nest one tuple inside of another. So for example, I've made a tuple called row 1 and another one called row 2. And then I make another variable altogether called table A, and I put those two tuples inside of that one variable. Now this variable has two tuples, and each tuple has individual elements inside of it. This is best represented by a table like in a spreadsheet. So if I think about this, I've got one row of data with 4 items in it, and another row of data with 4 items in it, and collectively they form a table. Now this is known as a two-dimensional tuple. By 2 dimensions, it means that there are columns and rows. So 1 dimension, 2 dimension. You can also keep stacking them together into like separate more dimensions. So if I were to add a spreadsheet here, that would be like a 3rd dimension, and I could have another set of values in that 3rd dimension. So that would be like a table. This would be like another table. And collectively, I could have two tables within this one spreadsheet, or this worksheet, I guess they call it. You can keep stacking them inside of each other as much as you want. There is a limit because it runs out of memory eventually, but it's pretty high. And to tell you the truth, you seldom stack them together more than 2 levels, and sometimes 3. I would say that for the most part, when you're working with a collection like this, 90% of the time, no, that's not true, 80% of the time, it's going to be a single row of data. And then probably 15% of the time, maybe a little higher, it'll be a table of data. And then seldom will you go, that last 5% is going to be when you exceed the 2 dimensions into 3, 4, 5. It gets decreasingly less common past that point. So if you can understand rows and tables, you're in good shape. That'll be a great way to get started in programming, and for the most part, that's what you use all the time. So for the rest of the time, you might go beyond that. Is pretty unusual. And when it occurs, you can just look it up. And you can use a for loop to loop through the rows in the table. And notice that I've got a nested for loop. So I grab one row of data, and then for each row, I grab the individual columns, column 0, column 1, column 2, column 3, and print them out. That's a nested for loop to go along with my nested tuple. And now I can control the way it's going to print out the data. Again, you can think of these tuples as a table of rows. A 2-dimensional tuple is a table of rows. A 1-dimensional tuple is just a single row. I'm using the word dimension, but you also see in the documentation the word rank. There's actually a few different terms. Rank and dimension are the most common ones, but certainly there are other ones as well. It doesn't really matter what they call it. Whatever language you're using, you'll recognize it pretty swiftly. See if you can make a table of values. Once again, we're going to try to print it out. Notice this time I've got the commas in between just to shake it up a little bit, and I'm actually keeping the default format just to make your life a little bit easier. So see if you can get that to print out. And then after you get this printing out, see if you can change it around a little bit. Add on a vertical printing of it. So print it out like this first, just to kind of get used to it and kind of understand how things work. And then see if you can change that. I've just added a line in here by just putting in multiple equal signs just to make it look pretty. That's all that is. Let's see if you can change it to vertical. And when you're done, come back to the video and we'll compare notes. I hope that went well. Let's cover how I did it. So first thing I did was kind of look over what I was trying to accomplish. There's several different parts of it. And then over in PyCharm, I copied the first labs and then pasted it. In PyCharm, it gives me an option to change the name over to a format. I just went ahead and changed it over to 2. I'll put an A there because I've already completed this. And notice that when it did that for me, it kept all the code I'd already previously typed. I just have to go through and start changing things for my new file. But a lot of the code is going to be similar. So I just start typing in the pseudocode and then coming in and filling in the blanks. Here's what I ended up with. So let's demonstrate how to create and print 2-dimensional tuples. A 2-dimensional tuple. Here's the data I'm trying to put into the tuple. I make a header tuple and 2 row tuples and add the 2 rows to the table. I don't need to add that header in there, but I could if I wanted to. I just chose not to. Makes it a little bit easier, because I'm just going to print out the header one time, and then after that I'm going to print out the individual rows. But if you chose to put the header in there too, perfectly fine. Control/. Now, by doing that, I didn't get that custom format that I wanted. So if I leave it out of there, I get the custom format. It's just about choices. Whatever choice you made is probably going to be just fine. And as I said, at first we're just going to print out the rows in the default format just to get you started. I print out, for cosmetic reasons, just a little bar across to separate the two results. And now I want to pivot the data into a vertical format, and all that means is I just grab a row, and then from each row I grab a column and print out the column, and I get that vertical format. So that's the way I solved my lab. Again, yours may be a little bit different, but hopefully it all makes sense. Like strings, tuples are immutable. And once again, you're not going to see much evidence of that. Just like you didn't see much evidence in the string, but it's true. And as such, they are, they have higher performance. They're designed to be high performance because once you set the value, if you're going to change the value, it's going to have to do some things. But other than that, it's just an efficient way to store a collection of data. So the fact is that if you add data to the tuple, you may modify the tuple in any way that's possible, because they restrict what you can do, then you'll get a different tuple. And it may not seem that way, but it's true. Now, to modify the tuple, it's kind of odd. I'm not sure why they use this odd syntax, but they did. Let's say that I want to add a tuple to a tuple. So I've got a tuple here, and I want to add a new value in. To add a new value in, you can't just add a new value to the tuple and expect it to work. It won't. Nor can you take an existing value, 0, 1, 2, so the value is 3, and change it to 4. That's not going to work either. Once the tuple has been created, they have restrictions on what you can do with it. You can't add on to it like this. You can't modify an element, just like you couldn't modify an individual character in a string. You can add a tuple to another tuple. So if I make another tuple, so notice the parentheses there, I can do the plus equal and add this onto the original tuple. So here's the original tuple. And I can add on a tuple like this. But the weird part is you have to use a comma to indicate that this is a tuple. Now there's a reason for that, because the parentheses indicates that we're just coming up with some kind of generic set of values, and it doesn't know for sure that this is a tuple. Remember that in Python we have a lot of automatic data typing for us, and tuple's a data type, it's a type. And so you need to use the comma there to indicate that that's your intention. Much like we have to put a dot 0 to indicate we want to float, even if we're not, it's just going to be a 3 or 2 or 1. We don't want an integer value. If we want it to be a floating point value, we have to use a dot 0 along with that number. So this just the syntax. It's I've always thought it was kind of confusing in Python. Most of the other ones aren't like that. Most of the other ones, other languages are not like that. But in this language, that is the case. So you just have to know that that's the case and kind of work with it. Sorry about adjusting this format, but When I see it, I have to fix it. So, not difficult to do, it's just tricky. And students fail on this all of the time. They forget you can't just add a value onto the tuple, that you have to add a tuple to a tuple, and you have to use this comma to get that done. So much so that I've stopped using tuples in the assignment because it was just making people crazy. It's not difficult, but no matter how I told people to do this in great big red letters, twice the size of any other letters, they'd still do it. So I've just given up. If you want to kind of play around with it, please do so, but we're going to move on. Another thing that we're going to use is the in operator. In operator is pretty handy because you can check to see if there's something in a tuple, a sequence really, not all the sequences, but most of them, that matches. So in this case, I'm looking to see whether or not Bob Smith is in this row of data, this tuple. And if it is, I'll print out customer found. If not, I'll print out customer not found. So it's just a real simple way of finding data in the collection, the tuple. Notice that if I do the same thing for Bob Smith on row 2, which doesn't have that, I of course would print out customer not found because, well, it's not in that row. And we see that. Why don't you see if you can modify your previous code so we can use the in. So make this table up of data and go and print it out. Then add code to display only a single row based on the row ID. So ID 1, 2, or 3, if they enter in 3, they would get this row of 3. Now you're going to do that by examining if that ID is in that row. We're going to create a for loop that prints it out and then allow the user with an input command to indicate which row they want to see. Give it a shot and then come back and you can compare your answer to mine. Okay, let's go over my answer. So, what I did, of course, is I copied lab 4.2 and renamed it, pasted it and renamed it 4.3, changed the header so it says create, print, and locate values in a two-dimensional tuple, change the description, and then change my little notes, add it in the third row, printed out the header, and then printed out the rows and made sure that that worked. So that was the easy part. And hopefully you got that part to work. The next part was a little bit more difficult, but I think I gave you enough hints. Let's see how you did. So I get an ID from the user, and then I start looping through the rows, seeing that if I can find that ID. Now do keep in mind that if you didn't convert it to an integer and you just use a string like I did here, it wouldn't find the row. I'm sure somebody probably did that. Can't find anything. That's because it's looking not at a collection of characters, not a collection of strings, it's actually individual objects of different data types. That's one of the great things about tuple, it can hold many different types of objects. So I need to tell it that it's a string I'm looking at. And I can do so either like this, or I could change it over here when I capture the data. You can see how the prefix tells me my intent, and sometimes that can be very useful and troubleshooting, as well as just making it easier to read. And there we go. Let's move on to lists. Lists are very similar to tuples, but they are indeed a lot more flexible. In fact, you're probably going to find that for the most part, unless you're worried about performance, you're probably going to want to use a list. Most scripts are very small. They're only doing a few thousand lines of code. So for the most part, your performance is not really an issue. It's only on very large applications that you'd have a whole lot of worry in that regard. So you're probably going to use lists over tuples most of the time. And because of that, we'll talk more about them in the next module as well. Now, with a list, instead of using parentheses, you use brackets. So parentheses and brackets are always square, although I'll say square brackets, because that's how I always heard it back in the day, but brackets are always square, so I'm just saying brackets is correct. And now I've got a list called V1. Now on the next line I've got a list called V2, and that's got the value 3. And unlike a list, a tuple, you don't have to have a comma. There's no comma there. You can also just add them together quite simply. They just are much more flexible. You cannot pack a list, so you can't use tuple packing. If you do this, it will believe that you want a tuple, and that's what you get. When you try to add the two together, it will fail. So you have to use square brackets always. In fact, I kind of recommend that you just get used to using the square brackets or the parentheses to make it really clear, so people don't have to, that are more novice, they don't have to learn about the difference. Just make your code easier to read. Anyway, there's also a lot of extra functions that are built into the list class. There's an insert function that allows you to insert an item in the middle of the collection. You can find an item and remove it from the collection. You can pop off the value of from the collection, either at the front or the back, using an index value or not. The I stands for index. You can get the index of a given item. You can say, okay, what's the item? This is basically looking in the list, finding it, and giving you back the index number, 0, 1, 2, 3. You can count how many items are in there. You can sort it. You can reverse the number of items. There's actually more than these, but you get the point that unlike tuples, there's a lot of extra things built into lists because, well, most people use them all the time. That also means that the more things that are built into it, the heavier it is in memory. So one thing that's about tuples, again, that they're lightweight. They don't have a lot of features. They are immutable. Lists are not immutable. They have extra overhead in that regard. They also have extra overhead in all the extra functions that are associated with it. But for the most part, you don't care. You just want to get the program working. And I can go ahead and create a list or a tuple almost identical. It's just that the operators are different. And it's easier to create a table. I don't know if it's easier, but it's certainly not any harder. I just make a list and add them in. So now I have a list of lists. That's a two-dimensional list. You can also put tuples inside of a list if you think that you're not going to change it. So I could actually add the tuple. The list will take all kinds of different data. Character data is certainly a thing, but I can also put in integer data. I can put in tuples. I can put in pretty much anything inside of a list, just like I can with a tuple. And then I can use those functions that are built in, like the append. I'm adding on a value. I'm removing an item. I'm inserting an item, a new row, at position 0. Or I'm sorting it. So you can see how I've got the two items, the list and the tuple. And if I print out, if I add it to a table and print it out, you can see that the default behavior of printing out the list includes not parentheses, but square brackets. So if you just say print the dimension, that's what you get. And of course, the same rules apply if you want to make it prettier, if you want to clean it up. You just have to run it through a for loop and clean it up using the same techniques we saw with tuple. Notice that I can append something. Like here, I've appended a phone number to that first row. It didn't show up in the second row. I can remove it. I remove that phone number, so no longer there. I can insert a new row of data, a new list at position 0. And if I sort it, instead of being 3, 1, 2, I can sort it, it'll be 1, 2, 3. Okay, why don't you try working with a list? So we're going to make a new lab. We're going to use code similar to lab 3, but instead of using a tuple, we're going to use a list. First thing is we just want to go ahead and verify that we can put it in a list and print it out. That's our first thing to do. Let's use vertical bars this time to, I don't know, make it pretty. And then after that, we will see if we can enter in some data. We'll get an ID, a name, and an email address from the user and add that on, append that on to the list. See if you can make that work, and when you get done, unpause the video and we'll compare notes. Okay, let's go ahead and see if I can make this work. So once again, I'm going to do the copy and paste. Let's see here. I can also do a save as. Let me do that. So save as does the same thing. And this is going to be working with a tuple, or list rather. So two-dimensional list. Create, print, and add values to a two-dimensional list. It starts off pretty much the same, except that we want to use square brackets. And since we can't use the packing feature, because that always packs a tuple, we got to put square brackets around this as well. Same thing here. Now these names aren't the correct name, so we have to be careful about that. You can right-click and change a name. Let's see, refactor, rename. Change it over to, I use LST for list. That's handy. You can also Shift-Alt, left-click and drag. It's on a Windows machine anyway. And I can type in LST and it'll change all of them. That can also be handy. Up to you how you want to do it, but that's one of the downsides of using a prefix, that you have to change it, and that's why some people just don't like using them. But I think that well, you know what I think. I've talked about it many times, so I will spare you talking about it again. And let's see if it works exactly the same way as the tuple did previously. Enter an ID. Yep, excellent. So far you can see that, yeah, it's almost identical to a tuple. Now let's see here. I want to change something. I want to change the way that this printed out. I want to have vertical, a vertical bar, like that. And that means I need to modify this. So instead of just printing out the row, I need to print out like row 0, row 1, and row 2. then I can just change the separator. To a vertical bar. That will match. Okay. That's pretty close to what we were looking at. I do see another vertical bar here. I would get that if I was doing certain things like a while loop or something like that. And if you have it on there, you can leave it on there. If you want to put it in there, I could just add it on after the fact. Let's see. I think it'd be kind of a pain to do that, to tell you the truth. I'm going to leave it like that. I could change this so the end is not a carried return, and then it doesn't matter. I'm just going to leave it like that. Okay, now what we're going to do is we want to enter an ID. We want to enter a name. We want to enter an email. So enter an ID, name, and email address. Let's change these variable names. So I'm taking integer ID. I'm taking string name. Actually, did I say we're capturing this as a string? So let's keep that as a string. And this will be string email. Okay. That should advertise our intent well enough. And since they're all coming in as a string, I don't need to do any conversion. Now, our goal is to capture that and create a new list from that. So I'm going to call it LST new row. And just put in the ID, name, and email. And our goal was to append to the table. Let's add that on. And I think that's it. Then we give it a try, see if it's going to work. So enter ID 4, Tim something, whatever it is. And address. Not very satisfying because I can't actually see the results. So I guess what I need to do is I need to print that out again. I'll just copy and paste that and put it down here. Not the most efficient way to do this. Print the list data as a row in the table. Okay. Not the most efficient way to do this by copying and pasting, but we're going to look at custom functions next week and see how we can make this a little bit better. For now, though, I'll just copy and paste. Okay, I think this is going to be better. Let's see what happens. Awesome, it worked. I think I got some more formatting stuff to do, but yes, it's working. Now, of course, every time I end the program and I start up again, it reverts back to its original form because, well, I lost all my changes. I probably want to make things more persistent so that I can, keep those changes I put in there. And to do that, we're going to look at writing to a file. Writing data from a list to a file is as simple as it is when you write data from a string to a file. So I would create my list, open the connection to the file. Notice I've just made it simpler. Tell it if I want to overwrite or append. Write out the individual values, any other formatting I think might be useful, and then just loop through the rows and write it out. Same as before. Just like before, you have to always double check on your operating system if you need an N, an R, or a combination. Always double check. But I would get the output in the text file, just like you would expect from when we did the string. Element 0, element 1, element 2 would be presented. And of course, if I wanted to change the way it was formatted, I could extract out the data individually and write it any way I want. We'll be working more with that. Certainly, we'll do some in the assignment. The assignment this week is going through and collecting data about home inventory, and then writing that data to a file. So you're going to put the home inventory data into a list that you collect, and then write it to a file, very much like this lab. Well, that's it for Module 4. In Module 4, we looked at strings and tuples and lists. We'll look at lists a little bit more in the next module, but for now, concentrate on understanding these questions, being able to answer these questions as if you were talking to a coworker or in an interview. So what is a collection of data, and what is another word for it in Python? What is a string? What is a tuple? What is a list? How do you work with them? And how do you save their data to a text file? Focus on getting these questions answered. The assignment will help you with that, and then when you're ready to go, I'll see you in the next module.